Hello, everyone, and welcome to our webinar on real-time media streaming over WebSockets to power AI. My name is Buket Kuşoğlu, and I am the Product Marketing Manager for Programmable Voice Products here at Telnyx. And I'm joined today by my colleague, Rafał Skorsky. He is our Technical Product Manager for Programmable Voice Products.
Hello.
So before we get started, let's quickly go over our today's agenda. And yes. First, we will start with what is WebSocket and its role in real-time media streaming, and then we will explore Telnyx Media Streaming API and discussing its benefits and most common use cases. And following that, we will have a live demo session, and Rafał will walk you through step-by-step how to set up a media stream over WebSockets. And after the demo, we will have some time for questions, so please feel free to share your questions in the Q&A box at any time during our presentation. And one more thing, don't worry, and after today's session, you will automatically receive a recording of this webinar. So let's get started. Rafał, over to you.
Yep, thank you, Buket. So let's start with some basics. So what is WebSocket? So WebSocket is, as you probably know, a computer communication protocol providing a simultaneous two-way communication channel over a single TCP connection. So comparing to the HTTP, WebSocket allows to have a very low latency due to the fact that TCP connection stays open, and thanks to that, the data may be exchanged very quickly without the need of repeated requests and responses. The WebSockets are very efficient in terms of data exchange because it is a binary protocol that's more effective than text-based protocols like HTTP. Of course, it's cross-platform because it is part of HTTP, so can be used from any platform. So WebSocket itself, it's something that is being used by us for media streaming. So media streaming over WebSocket provides an instant access to the raw call media and allow injecting it to the call as well using RTP stream. So in general, media streaming allowing forking the media from the call using WebSockets and as well sending back the audio to the call. What are the benefits? Real audio injection, well, I just mentioned. So it allows to integrate RTP stream effortlessly, allowing real-time audio playbacks on ongoing calls. Of course, thanks to media streaming, you can improve your scalability of your systems by using bidirectional streaming. You can smoothly integrate with existing AI, TTS, and STT platforms, allowing developers to easily scale your voice application. And of course, media streaming, maybe not, of course, because that is unique for us, as well support HD voices in 60 Hz frequency in order to deliver crystal clear audio quality. This is important in both directions. I mean, better audio quality on the call on this one side. And the second is that thanks to that higher quality of the audio, the transcription engines can be more accurate. So let's talk about some use cases for media streaming. Of course, AI-powered speech processing. This is probably nowadays the most crucial use case. And here it can be many things: voice assistants, bots that can analyze a response in real time. It could be used as well for keyword spotting and detecting specific terms in conversation, and of course, sentiment analysis. Well, I believe that in that section, the plateau of the scenarios is, I mean, it's not limited. It's only limited by our imagination. Of course, live translation and transcription, that media streaming can be used for that, for integrating with transcription services, with multilingual supports, what means that it can be as well translating on the fly. Media streaming over WebSockets, since it is raw audio fork from the call, it can be used for fraud detection and security reasons. like, for example, voice biometric as well to verify caller identity. And of course, it might be used for something that for now only conferences were used. And so it might be used for call whispering and coaching. So when you want to add the third leg, instead of complicating things with conferences and paying more, it is easier to use bidirectional streaming instead. So let's now talk a bit about the implementation. I would not focus much about this, what is written on that slide. I would rather like to encourage you to take a look at those getting started tutorials that are listed at the bottom. You need, of course, to have Telnyx account, establish voice API and XML or XML application, then create outbound voice profile for making outbound calls. And then if you want to have a number, it's not mentioned here, but if you want to have number assigned by number, assign it to the application and then just use it from either XML build or using dial endpoints. On my demo, I will talk a bit more about that, but I believe that are the basics that you can find on that tutorial, but I will try to more focus on media streaming. Okay, so media streaming, how it may look like. From voice API, it is supported from dial, answer, and dedicated streaming strat endpoints. Here's an example of dial endpoint, I mean calls, which making dials. And here you can see that there are only a few attributes that are needed: streaming tracks, streaming URL, the most important streaming URL, that is the address of your WebSocket server that will connect to and send the audio and get the audio from. And the bidirectional mode, I'll talk a bit about that in a moment, but in general, we've got two modes. Yeah, I will talk more in a second. Here's an example of the flow, how it may look like from the voice API application when you make a dial command and making a call. So first of all, we are making, as I mentioned, dial command, our Telnyx telephony service internal making a call to the desired caller. At that moment, the WebSocket is being established to your server. And once it is established, we are sending the first event, which is called connected. Then when the caller answers the call, except, of course, of other webhooks, we are sending streaming started webhook. I mean, other webhook like call answered. And at that moment, we are sending as well start event over WebSocket to your WebSocket server. The following, I mean, once people start caller and callee, or maybe only caller, start speaking, then we are sending the media event that contains the audio, the stream. You may get as well DTMF events, what means that if someone presses some keys on the call, you will get the DTMF event. On the other hand, in the other direction, you can send media event with your audio. You can send mark and clear events that can be used for if you want to know if something was already spoken, you can send the mark event after the media that's important for you. And once it is spoken on the call, we'll send you back the mark event. Yeah, it should be mentioned here as well that it might be mark. Clear means that you don't want to this media that's already sent to be spoken on the call, what means that the queue is just being cleared. Yeah, and we are just waiting for following media events. Once the caller or the callee hang up the call, we are just sending stop event and the connection to the WebSocket is being stopped. And of course, streaming stop webhook is being sent to your voice API client. So this is the flow. Here you can see how to enable it from XML. We support two ways. One, it is just within start verb, you can add stream verb, none after that, and define all the connection details similar to voice API. As well, you can use connect instead of start. And the difference between those two ways is that connect is blocking, what means that the next operation won't be run or executed until the stream is running. In case of start, the stream will be started, and the following of instructions will be executed immediately. Yes, and you can use as well dedicated TextML REST endpoint for starting stream. So you are not only limited to the TextML streams. Yes, and now let's talk about bidirectional streams. This is those two types that I mentioned before. Historically, we supported only one, MP3, but now we've got two, and that I believe makes this feature more capable and better for integration with all the AI solutions. So this first very basic is based on the files, MP3 files. That simplifies the solution on your side for your middle layer. However, it is designed for longer playbacks. If you try to use very short playbacks, the gap between them might be noticeable. So if you have the real-time streaming, the RTP option is for you. This is designed for low latency audio streaming. To the call, it uses RTP streaming. That means that your middle layer will be more complex. Yeah, I mean, we'll see that in the moment on the demo section. It is not very complex, but yeah, definitely file-based is a bit easier. Yeah, so here, now I would like to talk with you about the encoding of the stream, because for many of our customers, I mean, it is not the easiest thing. So let's talk this technical aspect of media streaming. So I believe that's the right place now to discuss that. So let's start with the outbound stream. Outbound from Telnyx perspective, what means the audio that we are sending from us to you. The encoding can be set. I mean, we are sending using the same codec as is negotiated on the call. So if the PCMU was negotiated on the call, you will get the streaming using the same coding. So we are not doing any transcoding in that direction. And your preferable codecs can be set on voice API application settings for inbound calls. And for outbound calls, you can use preferred codecs field in the dial transfer or transfer commands or in TextML to set the codecs that you want to have. Yeah, what is important that of course we can negotiate only those. I mean, if you are making external calls to PSTN vendors, we can use only those codecs that they support. Of course, for telephony, default codecs are PCMU in the US and PCMA in EU. But if your scenario is to make Telnyx in-house, I would say, calls, then you can use as well HD codecs. You can use higher frequency and so on. Yeah, and for streaming encoding, I mean for inbound stream, so the stream from you to us, you can set it as part of every command. For every command, we've got a parameter which is called streaming bidirectional codec. And using that field, you can set the codec that you are going to use for sending us the RTP stream. You can use all the streams that are HD streams and any streams that are supported. Please be aware that it will, if it's not aligned with the codec on the stream, it will be transcoded, what means that the quality might be reduced. Transcoding, and one more point, transcoding is not supported for AMRR WB codec. In that case, if there is misalignment between the stream and the codec on the call, you will get an error because we cannot transcode that codec. Yeah, but what if your AI or any other system that you are integrating with supports only PCM? In that case, the client middle layer needs to transcode PCM to the codec that is supported by telephony. And here are a few options. For example, for PCMU and PCMA on Python, you can use audio op library. I will show you that on the demo how to do that. You can use as well PY-AV library for codecs, for HD codecs like Opus, AMP, and WR. And for Node.js, PCMutil for PCMU and PCMA, and FluentF FmpEg library for other codecs like Opus and AMB WR. This PY-AV as well requires FmpEg to be installed on the server. Yeah, so now it's demo time. Let me switch now the sharing to the IDE. Yes, so the first demo that I wanted to show you, it's a service written in JavaScript, so Node.js service. This service is built based on Fastify, as you can see, and that's what it is doing. It is just establishing the, based on inbound calls, it is sending XML instructions that is starting the stream to that middle layer. That's one end of the system. And the other is sending that audio that we are getting from Telnyx to OpenAI speech to voice-to-voice service. On the other hand, everything that's generated by OpenAI voice-to-voice is as well sent to Telnyx and can be heard on the call. So this is end-to-end AI assistant or chatbot solution. Yeah, and how it's built. So as I mentioned, we are just exposing that XML instruction for each calls that are coming. So when the call is started, we are sending Telnyx is sending a status callback for instructions to that server. This service is responding with just a quick say at the beginning that we are waiting for connecting, and then it's starting the stream connection to that middle layer application. Yeah, so here is the code that's responsible for setting up the WebSocket, as you can see. It's under media stream. We are just starting the WebSocket. Then, sorry, this is WebSocket to OpenAI connection. Sorry, this section is to OpenAI. So this is connection because we are going to use two WebSockets. One is between Telnyx and that middle layer, and the other is between middle layer and OpenAI. Yeah. So this when the connection is coming from Telnyx on the WebSocket, then we are establishing OpenAI connection, and this is the code that's responsible for that. And here is the section that's waiting for messages from OpenAI. We are just based on the audio, the audio delta. This is the type of message that we are getting with audio from OpenAI. And based on that, we are creating a message. This code is creating a message that is going to be sent to the to XML connection. It is the object that is responsible for WebSocket to connection to Telnyx. So this is the inbound streaming from Telnyx perspective. The outbound streaming, so the audio that we are getting is handled here. So based on the media event, when you are getting the media event, we are just creating the audio append event. This event is being sent to OpenAI. And in general, that's it. Yeah, that's everything what you need. In general, in 170 lines, you can have media streaming connections bidirectional to OpenAI from Telnyx. Yeah, there's one more example. I mean, I believe that we could run it, but probably you won't hear much from that call. I would rather encourage you to just test it by yourself. Instead of that, I will show you one more example written in Python. I don't know, Buket, can you confirm that you can see the screen, or
yes, it's seen now.
Or maybe let me show it once again, because I'm not sure if it is switched. So
okay.
Yeah, so this project, which I'm presenting you now, it is our chatbot, Telnyx chatbot, that we created and integrated with PipeCut solution. I don't know if you're aware, the PipeCut is pretty known now, open source solutions for building AI assistant solutions, not only, but mostly about that. And we created our chatbot there as an example application. That's exactly what you can see on that screen. The links, by the way, the links to those demos will be in following slides, so don't worry, you can get back to that and review that by yourself. Yeah, so here is how those bots are created on PipeCut. You are just provided some that what should be used, I mean, as a WebSocket parameters. And here is the crucial thing, Telnyx frame serializer. That is something that allows to serialize the frames that you are getting from Telnyx and translate it to something that will be understandable by PipeCut. And as well here in that flow, we use Open AI LLM service for text, only for text without audio, DeepGram for transcripting, and 11 labs for generating playbacks in general. So this configuration is passed to pipeline, and based on that is creating the bot. But that was interesting. What I wanted to show you is that what I mentioned before. It is how to transcode from PCM to the telephony known codecs like ULO or ALO. It is in that case using this audio op library, just using that the function within that library allows you to transcode the audio from PCM to desired codec on the call. So if you have any issues with that, this is a good example and good starting point with transcoding to inspire you, or just use similar code like that. So that was 2 demos that I wanted to show you. Now let's get back to the presentation. Let me share others. Sorry, not that one. Just a second. Okay, demo, can you see it? Sorry, I need to share it once again. Okay.
Yes.
Okay. Yes. So on that slide, as I mentioned, are all the links. So PipeCut is that what I presented to you, and as well OpenAI. So 2 last links are. I mean, if you want to review that once again, the demo applications are there. There are some others as well in our Git repository, like integration with DeepGram. And integration with our internal transcription engine. There's one more link to our tutorial in our dev documentation. You can get their specification of all the events that we are sending and more information about the flow. Yes, so we are getting now to the questions.
Yes, thank you so much, Rafael. Let's start with common questions. The first question.
So yeah, sorry.
Yes, here I can see it now. The first question is, what does it happen when the call is answered before the WebSocket connection is established?
Yes. So in that case, we are buffering the audio, so you will not lose any audio in that case. We are just we'll send it once the WebSocket connection is established. So don't worry, everything will be fine. The speech won't be cut, even if WebSocket connection is established later after the call is answered.
Okay. And does Telnyx guarantee the order of package for media streaming?
And this is not easy question, but I added it here by purpose to answer it. To be honest with you, I mean, in general, we don't guarantee the order of the packages. And the reason for that is the fact that, of course, the WebSocket connection between your middle layer and our media streaming service is over TCP. So in that case, the order is guaranteed. But internally, between that media streaming service and our telephony service, we have to use UDP. There's no other option, yeah? And in that case, it might be like that it is not very likely, never happened. No one complained that, but we want to be honest with you that sometimes it may happen that the order will be as on the call, yeah? That some of the packages may be misordered, but as I said, it's very unlikely and it never happened so far.
Great. And one more question. On documentation, I read that media sending is permitted only once per second. What does it mean? I tried sending multiple medias per second without any issues.
Yeah. So this once per second is for MP3 file mode only. If you are using RTP stream, you can send, of course, as many messages as you want. I mean, with probably with the not higher frequency than the audio that you are sending to us, but in general, 20 milliseconds packages are supported. So this one per second, it's about MP3 base bidirectional streaming. Okay, so the following question here.
Yeah, one more question. When using only 8K, how accurate is the transcription?
And that depends on many aspects. That depends, of course, on the engine that you're using. Of course, using HD voices would improve, as I mentioned before, the accuracy of the transcription. On the other hand, it's good to use noise suppression, the feature that we have to cut the noise, which might be behind on the audio. In general, I would say that most of the transcription providers can generate pretty good, even with 8 kilohertz ULOW audio, pretty good transcription of it.
Okay, perfect. And one more question. Hello, my use case is to use Telnyx as a real-time language translator between two users, which is bidirectional communication. So how can I implement that?
Yeah, so please, I would encourage you to see that first and second examples, the links. They're mostly about that. I mean, yeah. So please, of course, it is about as well the transcription provider that can make translation for you. But from the integration perspective, those two links covers that. I mean, your scenario, I would say.
And one more question. How faster is the use of 11 Lab streaming from your HTTP speak endpoint?
Let me try to understand the question. Yeah. The question is more about using what is faster, using streaming or text to speech 11 labs. I mean, speak command from voice API. Okay, so that depends on the scenario, because when when you're using AI, you can AI solutions. You can using real-time generating text from your chatbot, and in that case, you can use as well real-time generating of the speech from solutions like 11 Labs, and send that over media streaming, and that will be faster than waiting for the full text that you are going to send to 11 Labs and generating, for example, the full sentence from them and passing that to the call. So if you want to have real-time solution, bidirectional streaming is better. If you are fine with generating longer speech, like based on the sentence, using the speak command should be as well good.
Okay.
The last question is not technical.
You can buy our Telnyx hoodies from our website. We have a shop over there. So if you like it, you can buy our hoodies on there. And I think I am checking again, but these are the whole questions that we have. So, but if you have any questions, additional questions later while we are trying these by yourselves, please feel free to reach out through our website. And also at the end of this presentation, yes, in here, you can also find the links to all our helpful resources. And I think that's all from us for today. And thank you once again for joining us. And
one more thing, of course, if you have any, if you want to contact over Slack to me and have more specific questions, I will be happy to answer. Just register or to the XDev channel, and then you can send me direct message on Slack, and I will be happy to answer.
Yeah, great. Thank you. Thank you, then. Have a wonderful day.
Thank you. See you next time. Bye-bye.
Bye-bye.